Welcome back to Mr. Hassan's Maths channel. I'm now going to be answering question number 6 from the January 2020 International A-Level Edexcel S1 paper. This question here is about discrete random variables again. Okay, very popular question. So I'm answering this question on the request of certain students who've asked me to on the channel to answer this question. So that's what I'm doing here. Now, it says a tennis tournament has 5 rounds. 5 rounds. After each round, winners go into the next round and losers are knocked out of the tournament. To enter the tournament, players must pay an entry fee of $10, but only the person who wins all 5 rounds receives the prize of $260. Now, Serena enters this tennis tournament. The random variable S represents the total number of rounds that Serena wins. The probability distribution for S is given in the following table. So a discrete random variable is always something that has a numerical value. So in this case, it's the number of rounds that Serena wins. So if she wins 0 rounds, that means she's been knocked out. Okay, knocked out in the first round of the competition. Okay, she competed in the first round, she got knocked out. If S equals 1, that means she's won the first round and she's gone to the second round and got knocked out of the competition because she only won 1 round. If she's won 2 rounds, that means she's got to the third round. She's won the first round, she's won the second round, she's got to the third round, but she lost in the third round, and so on. So if S equals 5, that means she has reached all 4 rounds and won the 4th round. She's reached the 5th round and won the 5th round. So 5 rounds. So if she's, for example, if S equals 4, means she's got to the 5th round, but she didn't win it. So S equals 4 means she won the first round, she won the second round when S equals 2. When S equals 3, she won the third round. When S equals 4, she won the 4th round. Okay, but she didn't win the 5th round. For her to have won the whole competition, she has to win also the 5th round. Okay, so the value of S tells you how many rounds she won. Okay, how many rounds she won. And as I said, a discrete random variable is always a discrete number, a particular value, okay, which has to be a number, it has to be a numerical value. Okay, so for example, if I say, when you toss a coin, will you get heads or tails? Well, heads or tails is not a numerical answer. Okay, so therefore that's not considered a discrete random variable because the answer is not numerical. But if I say, if you toss a coin 4 times, how many heads will you get? You can either get 0 heads or 1 or 2 or 3 or 4. That's considered a discrete random variable. Okay, it's random because you don't know until you have actually carried out the experiment what's going to happen, and every time it might be different. Okay, one time you might throw the coins, you might get a certain number of heads. Another time you might get another number of heads. You don't know before you've done it. That's why it's random. So it's discrete and random, and it's a variable. Okay, discrete random variable. Okay, so that's an example of So for example, if I say how many months in the year, well, that's not discrete random variable. That's fixed. We know there's 12 months in the year before we even start counting them. So it's not a random variable. See. All right, so now, let's go ahead now with the question. Just a bit of an introduction to what discrete random variable actually means. So now, here we have to show that k equals 20 over 49. Now, this probability distribution tells you the probability of each of these events occurring. So this is the probability that she gets knocked out in the first round. She doesn't win any games. This is the probability that she gets to the final. She's won 4 rounds, but she doesn't win the final. So she gets through to the 5th round, but she doesn't win it. Okay, so these are the probabilities of all of those events happening. Now we don't know any of those probabilities in exact form. We have them in terms of k, but we can use a piece of information that we should know, that the sum of the probabilities is always equal to 1. So if I know that if I have k and I add to it k plus 2, k divided by 2, and I add to that k over 3, and I add to that k over 4, and so on, plus k over 5, plus k over 6, I know the sum of all these has to be equal to 1. Now, to solve this equation, I could add all these fractions together and then cross multiply, or I could do something like this to get rid of the fractions. If I multiply this side by 60 and all of this side by 60, I will get rid of the fractions and I'll be able to solve it a bit easier. So 60 times k, that's 60k. 60 times k over 2, that's 30k. 60 times k over 3, that's 20k. 60 times k over 4, that's 15k. 60 times k over 5, that's 12k. And 60 times k over 6, that's 10k. That's equal to 60 times 1, which is 60. Multiply both sides by 60. So that's going to give us 90, 110, 125, 135. 135 plus 12 is 147. K equals 60. So K equals 60 divided by 147. If I divide both of these by 3, because that's 5 plus, yeah, that goes, 3 goes to both of them. That's going to be 60 divided by 3 is 20. Divided by 3 into 14 goes 4 times, remainder 2. 3 into 27 goes 9. 20 over 49. And that's what we had to show. Okay, we had to show that K equals 20 over 49. So there's the answer to part A of this question. Now moving on to part B. It says find ES. ES means the expected value of S. The expected value of S. It's kind of like finding the mean of this data. So what I have to do is, what I'm going to do first, I'm going to fill in this table with the actual values of the probabilities. So I know for the first column it's K, which is 20 over 49. For the second column, it's K divided by 2. So it's 20, it's like a half of this, half of 20 over 49, which is 10 over 49. And for S equals 2, which is the third column, you have K divided by 3, so it's going to be a third of 20 over 49. Well, 3 doesn't go into 20, so let's figure out what to do with that. We have here 20 over 49 divided by 3. Over 49 divided by 3, which gives us 20 over 147. That's 20 over 147. And when the fourth column is going to be K over 4, so it's 20 over 49 divided by 4. So I'll just do that from now. So 20 over 49 divided by 4, that gives us 5 over 49. And 20 over 49 divided by 5. So I'll just, that gives us 4 over 49. And we got divided by 6 now. So divide that by 6. Divided by 6, that gives us 10 over 147. 10 divided by 147. Okay, so now we've got to find the expected value of S. We've got to find what ES is. Expected value of S. Well, that's like finding the mean from a frequency table. This is kind of like a frequency table, except it's a probability distribution table. So we have to find the product of these particular entries and their probabilities. Okay, so the random variable time its probability and find the sum of all of those gives us the mean. The expected value means the mean. ES means the mean. So here you got 0 times 20 over 49, so I don't bother writing that down because it's going to be 0. 1 times 10 over 49 plus 2 times 20 over 147, that's 40 over 147. 3 times 5 over 49, so that's 15 over 49. 4 times 4 over 49, so that's 16 over 49, plus 5 times 10 over 147, which is 50 over 147. Okay, so that's going to give us the expected value of S. So let's figure out what that's going to be. So we have 10 over 49 plus 40 over 147 plus 15 over 49 plus 16 over 49. Whoops. Plus, and the last one here was, oops, what have I done here? Sorry about that. Let me move this out of the way. Okay, plus 50 over 147. And that gives us 71 over 49. So you can say this is 71 over 49. I'll leave it like that in this exact form. That's fine. That's good. We could round it to 3SF, I guess, but I'll lift it at this fraction. That's fine. So that's the value of ES, the expected value of S. Now, part C says, find Serena's expected profit if she enters the tennis tournament. So the expected profit, now, she's only going to get any money if she wins the tournament, okay? If she wins the tournament. And the probability of her winning the tournament is 10 over 147. That's the only time she'll get some money. So it's going to be 10 over 147 multiplied by the amount that she gets, okay, which is 260. That's the expected income. That's the expected income. That's like the probability that she wins is this, times the amount she gets if she wins is that, and that's the income. You got to find the profit. So you got to take away from that the cost of entering the tournament, which is $10. That's how much it cost her, the entry fee. So that's going to give you her expected profit, okay? Because she's not, guaranteed to win the competition. That's the probability that she'll win the competition. So you multiply that by the prize money, take away the money it took her for entering the competition, and that will give you what's called the expected profit. So let's work out what that is. So you have 10 divided by 147. And you multiply that by 260. And then you take away the 10. That gives you the expected profit, which is 7.687. 7.6870, which is $7.69. So you write it to 3. That's expected value. That's expected profit. Expected profit. Okay, for what's her name? For who's this? Her name again? Serena. Okay, so that's the answer to part C of this question. Now for part D. Part D says, Roger also enters the tennis tournament. Given that Roger is still in the tournament, the probability that he wins the next round is a constant P. The random variable R represents the total number of rounds that Roger wins. So the probability that he wins is equal to P. And the probability that he loses, therefore, is equal to 1 minus P. Okay, that's obvious. So now, we got to find the probability that R equals 2. R equals 2. Okay, that's equal to the probability that he wins the round 1 plus the probability that he wins round 2 plus the probability that he, not plus, times, sorry. Let me just explain that again. Okay, he's got to round 3 and he's lost round 3. Okay, so the probability that R equals 2 is equal that he wins round 1, and then he wins round 2, and then he loses round 3. Okay, so probability that winning round 1 times winning round 2 times losing round 3, that will give you his answer. So now the probability of winning is P. This is P. Again, P. Winning, P. And then losing, that's going to be 1 minus P, which you can see is P squared times 1 minus P. So there's the answer for probability that R equals 2. Okay, that's the probability that he wins, he wins round 1 and he wins round 2, but he loses round 3. So that means he's won 2 rounds. Okay, so that's p squared times 1 minus p, as they ask us to show. Then it says, find in terms of p the probability distribution for r. So we got to do something similar to the table that we had here, but in terms of r. So instead of s and s equals s, we'll have r and probability of r equals r. So what we're going to do here, we have r this time, and we have the probability that r equals r. Let me just make this a bit neater. So we have r, and we have the probability that r equals r. So again, he could have the following outcomes. He could win 0 games, which means that's going to be the probability of that is 1 minus p. Or 1 game, that will be p times 1 minus p. Or 2 games, that will be p squared times 1 minus p. Or 3 games, that's p cubed times 1 minus p. Or 4 games, that's p to the power 4 times 1 minus p. Or 5 games, that's p to the power 5. That's where he wins all 5 games. Okay, let me just make this a bit neater on top here. So that's 1, 2, 3, 4, 5. Okay, so that's part E done. So we just done the probability distribution. Pretty simple in terms of P. Then it says, find the smallest value of P such that Roger's expected profit is at least as great as Serena's. So the expected profit for Serena was equal to 7 point something. What was it? Was $7.69. Okay, or we could say, if we want to, in its more exact form, we could say, let's have a look. $1130 over 147. 1130 over 147. 1130 over 147. Yep, okay. So that's expected value for Serena, or expected profit for Serena. That was the answer. Now the expected profit for, what's his name? Roger, is it Roger? Yeah, is going to be basically the probability that he wins, okay, which is p to the power 5, times the prize money, which is 260. Was it 260? Yep, times the prize money minus the cost of entering. So it's going to be 260 times p to the power 5 minus 10. And we want to make sure that that is greater than this value here. So therefore, we're going to say that the expected profit of R has to be greater than or equal to, at least as great as. So greater than or equal to the expected profit of Sally. So we can say that this 260 p to the power 5 minus 10 has to be greater than or equal to 1130 over 147. Okay, so that means p to the power 5 is going to be equal to 1130 divided by 147 plus 10, and all of that divided by 260. So 1 over 260 times all of that. Okay, that's p to the power 5. So let's work out what that is first. Okay, so that's going to give us that plus 10. That plus 10. Okay, and then that's that. Right, then you're going to have divided by 260, which is 10 over 147, and then we got to, yeah, that's it. So it's 10 over 147. So p to the power 5 is equal to 10 over 147. Therefore, p is equal to, we've got to find the fifth root of that. So we take the fifth root of this. So we have to shift. We've got fifth root of our answer. Whoops. Of our answer. That gives us 0.584, 0.58416, goes on like that. So therefore we can say that P is equal to $0.58. Okay, so there's the answer to part F. That's the smallest value of P such that Roger's expected profit is at least as great as Serena's. So that's the value of P for which they'll be basically equal. Okay, so that's what we can say over here. That's the answer to question number 6 from this paper, January 2020. I hope that was clear. Other questions from this paper can be found in the playlist that should appear on the top of the page here. Other questions from discrete random variables of S1 in the playlist over here. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.